Okay, question 19. K closest in sorted array. Given a target integer t, a non-negative integer k, and an integer array A sorted in ascending order. Find the K closest numbers to t in A. If there is a tie, the smaller elements are always preferred. Okay, so the function K closest, there are three input. First is an int array, the second is an integer for the target, the third is an integer for K, and the return type is int array. And the assumption here is that the input array is sorted in ascending order. And possible corner case is when array is null or the length is 0, or when k is less than 1, then we can just return an array with 0 size. And another corner case is when k is greater than the array length, then we just return the entire array. Okay, so the solution here is to use the binary search to first find the index of the closest number, and then starting from that index, we add k numbers to the new array. Okay, so looking into the code, the first part is sanity check. First, we check if the array is null or not, and second, we check whether the length is 0 or not, and third, we check if the k is less than 1. If any of these happen, we return a new int array with 0 size. And another corner case is when k is greater than array.length. When that happens, we return the entire array. Okay, the next is to set out the pointers for binary search. Left is 0 and right is array.length -1. These two pointers define the search range. And next is while loop. The condition of the while loop is left less than right -1, meaning when there are only two elements left in this search range, we don't go into this loop and we do the post process. We're not doing this because we try to avoid that loop. Okay, now looking into the loop setting. First, we set up the int meet to calculate the meet index, and then we compare the meet element to the target. If it's the same, then we find the closest element. We set the left pointer to meet, and the right is left +1, and then we just break here. And if the meet element is less than the target, then we know the target is in the right side of the array. Then we move the left pointer to the meet. Otherwise, we move the right pointer to the meet. Okay, and then when there are only two elements left in this search range, then we get out this loop and we do the post process. So for the post process, in the beginning, we set up a new int, and the size of the new int array is k. And then we set out a for loop to collect k elements from the array. So the starting I, we set up to 0, and then I need to less than k, and then I++. And then we use the if statement to decide whether we pick left elements or the right elements. So there are three conditions here. The first is we check whether right pointer is out of bound or not. If it's out of bound, then obviously we pick the left elements. And then another condition is in order to pick the left elements, the left is must not out of bound. So left need to be greater or equal to 0. And also the left compared to the right, it needs to be closer to the target. And when that happens, yes, we pick the left elements. So whenever we pick the left elements into the new array, then we need to move the pointer backwards. And if, for example, if the right is not out of bound and left is out of bound, or the left is not closer to the target compared to the right, then we pick the right elements. When we pick the right elements, then we move the right pointer to the right further. So at the end, after we collect the k elements, we return the new int res. Okay, so the time complexity of this function is log n plus k. Log n is because for the binary search, we reduce the search range by half in each iteration. And then for the k is because we collect k elements into the new array. So in total time complexity is log n plus k, and the space complexity is O1. Because in each iteration, we don't create a new object or new variables. Okay.